Hello everyone, in this video I wanted to talk about X99 Chinese boards and overclocking, especially RAM overclocking actually. So the things that I found interesting was that there are actually three different types of ACC registered memory implementation for these boards. As you will run these boards with a cheap server RAM, this comes with error correction. Now error correction can be implemented by the different BIOSes in three different ways, as I found. So the first way is that ACC error correction is disabled. So what happens is that you will find errors in the test, in the benchmark. So the benchmark will show errors here in the check phase, around here, and the programs will crash. And so you will find instability in this hard way. And of course, when using the same memory settings for the same sticks of RAM as I did, I found I found that in the hard way by swapping different BIOSes with the same memory settings, and so some BIOSes would just crash the program and show errors in the error checking, but we're having higher scores. While some other BIOSes, so the second kind of implementation that we will have is that error correction will be enabled, but it will show no errors in the hardware errors, Windows hardware errors implementation. And this is like the most common way to have this with the modified BIOSes. Like for example, with this X99 TF board, I think the stock BIOS didn't have error correction enabled. It was from 2019. Then I flashed one BIOS from the Micron's X99 application from Micron's hardware, and that BIOS had error correction enabled, but it was not showing in the Windows error. And the third BIOS that I tried was from this GitHub from Koshak 1013. I used the recommended BIOS for X99 TF. So this page is originally in Russian, so you have to get a translator app like for this. So this is Firefox, and it's translating the page. And I use the recommended BIOS for this board, which is actually like the main BIOS is from 2020, but they actually like kept updating it since then. And so this is actually like I think the latest update was from 2023. Yeah, it was well, last year said so. But it's still like as much as I found it, as much as I researched, this one is the best BIOS available for this board. I also used the Ultimated Patcher tool to actually enable the all-core overclock, all-core turbo boost. And with this BIOS, the voltage offsets inside the BIOS are actually working, and they combine with the turbo boost unlock. I know this sounds like if you want to understand this, we will go to the BIOS to see that, and it's very, very useful to test the undervolt with the all-core settings. And this BIOS will actually show errors in the hardware info with Windows hardware errors interface. And this is super useful because if you have error correction enabled, but you don't see the errors in the hardware info app, you don't see the errors anywhere, they're not reported. It is much harder to understand whether your RAM is not stable because the errors will be hidden. You will have some drop in performance because when you hit error correction, you have a huge hit in performance. But if you don't see that, you actually have to look for it in the scores of the test, the benchmark runs. So for example, in this case, you will have a slight reduction in the score as the chip will get hotter, because you are actually TDP limited. It's like that your limit is the power 130 watts power limit. But if you have error correction enabled and your RAM is spitting out errors, what happens is that you will have random scores. Like this score will randomly go up and down, and you will not understand why unless your BIOS actually reports the errors on this interface. And that's the most interesting part. So you really have to test it. You really have to find some memory that have ACC. and try to push it to the limit, and make sure that you, at some point, you will find errors. The best way to get errors out is to get higher refresh interval, and this is the fastest way to get errors. It's also a very good way to improve performance. And for example, with this kit is of DDR3. I was actually able to run at 2133 mega transfers, memory transfers. But at that speed, I would need to get a very low refresh rate, and in the end, the performance was lower than running at 1866. So these are the current settings. I will now go to the BIOS and show more. Oh well, first I wanted to show the scores for this. So this is PyCruncher. This is RIM packets, of course, 8 GB. This is Cinebench. This one has all-core boost. The undervolt is set in the BIOS with -80 on the core and -60 on the cache and -55 on the system agent. I think I get the system agent lower now that I lowered the memory clock in the end. So yeah, let's go to the BIOS. So here you can see the main information about the BIOS revision. We'll go to memory configuration. I can actually run this same timings at 2133, but it will start to spit errors as soon as I start Limpack, of course. If you go to timings, so refresh rate is quite high for DDR4, DDR3, and to run at 2133, I need to lower that to like 9000, and the scores in most tests are actually worst. So these are pretty good timings for DDR3 running at the speed. I had to make sure that I had a lot of fans for the RAM, because the RAM gets hotter and it will start to error if you run the test for a very long time. Also, this custom cool, I didn't build it. I didn't build this liquid cooler system. It's spitting hot air inside of the case, so that's a concern. And the best way to test this kind of setup is to run games like Warzone. Warzone is extremely taxing on the RAM and extremely taxing on the GPU, of course, and we will proceed to do actually that. So last thing about the BIOS is that in this BIOS, and this is not usually working for this kind of BIOS, but with the Koshak mode it does, I actually can use this to set the undervolt, and it will still work together with the turbo unlock that I set with the ultimate patcher tool. And this is very, very useful to test the undervolt, because the undervolt is different if you enable all core boost. So I will now proceed to play a little bit of Warzone, which is a very good benchmark for stability. And the best thing about having error correction showing errors is that you can play any kind of game, like use the computer normally. As long as you keep up hardware info, you will find instability, and that is very, very useful to have. Here we are. So as you see, the score is quite good for the CPU. I actually GPU limited for some reason with the Vega, but this Vega is not overclocked. And I will try to drop in the central hydroelectric plan to provide for useful experience, and you will see. And here you see it's around 100 FPS. This is the first part of the game where there are more player active, so the performance is at the lowest. It's still a pretty good showing, and as you can see, the GPU time is very similar to the CPU time. This machine will actually end up as a Hackintosh. It's actually already a Hackintosh, and it came in for updates and performance improvements. And yeah, that's it. The performance is, as you can see, is pretty good for this game. And that's all, I guess. Ciao, ciao.